In this video, we're going to use a graph to determine intervals of increase and decrease. And they give us this polynomial. This would be like minimum fourth degree polynomial because you can see that we have 1, 2, 3, 4 x-intercepts and 3 turning points. So the first thing we're going to do is we're going to go through and we're going to mark out the local mins and maxes. So we have right here, this would be a local max. Down here we would have a local min. Up here we would have this would be a local max, but it just so happens to also be the absolute max because that's the highest point on the graph. So we're going to call that absolute max. They want to know where this thing, it says determine the intervals for which the function shown below is decreasing. Every time you hit a max, that tells you you're going from a positive slope to a negative slope. And every time you hit a min, it's going from negative slope to positive slope. So we're going to look for basically the maxes, because when we start with the maxes, that's where we're starting to decrease, because that was our maximum point on the graph, and now we're going downwards, meaning we're decreasing in slope. So we are decreasing from -5 to -2 here. So I'm going to write decreasing. And that would be from -5 to -2. And at -5 and -2, our slope is 0 because that's where it flattens out. So we're going to put parentheses here saying we're not decreasing at those 2 points. But we're also decreasing from 2 all the way to infinity. So from 2 to infinity in the x direction, we are decreasing as well. And these are all x values, so that's something important to note, that this is all x values. We're describing where this thing is decreasing at. For the increasing, even though they don't ask for it, I'm going to do it anyways. We're going to be increasing from -infinity up to this -5. And then we're going to union that with where we're increasing here, which was from -2 to 2. And that's how you determine intervals of increase and decrease.